In this video, we're going to talk about and cover the process of applying keyline patterns inside of Google Earth. Now, this video is going to be different than all the others. It's not going to be so edited because I believe it is important to capture the process of going back and forth between making mistakes and making corrections so that you can see all of that. Also, we are going to talk about certain concepts that are related to applying this geometry, and we're also going to cover some of the theory that comes into play when you're applying these kinds of patterns in an application like Google Earth Pro, which doesn't have very sophisticated CAD tools like offsets and so on. So the theory that we're going to cover will allow us to still apply this pattern fairly accurately. It's not going to be as accurate as a CAD application, of course, but it's going to come very close. And once we have covered the theory, we can go straight into applying the pattern on a real project. Now, the first thing I wanted to cover is where this pattern, or really any other pattern, fits into the larger process of landscape design. And then more specifically, we're going to take a look at the process of how we draw this pattern out in an application like Google Earth, or even if we were to do it by hand using traditional hand drawing tools. So here I have the Regrarians platform, and we can see all of the layers. Now, what I want to bring your attention to is that the keyline patterning, as well as any other pattern, be it grid or offset or a contour pattern, they're all going to generally come down towards the very end of the platform. Now, this platform is not necessarily a linear process, but the pattern is never going to be the first thing that you start doing when you start creating a concept for a landscape, even if the point or the purpose of the concept is to create the pattern. So the pattern is always going to be preceded by something else that you have to establish. Now, regardless of which layers of the platform are applicable to your site or project, there are always going to be at least two of them that will apply before you can even start creating the pattern. Those layers are the geography and the axis layers. Under the geography layer, for example, you can consider the slope of the site. Some slopes are simply too prohibitive depending on how you're going to apply this pattern. If you're going to use machinery, then you need to be especially careful. And you can also consider the roughness of the terrain. Now, even if you have a slope that is just 10 degrees, if your terrain is very rough, like there are many bumps or rock outcrops and so on, then those slopes can also be quite dangerous if you're using machinery. And under the axis layer, regardless of whether you have any roads or not, you have to consider headlands, which is the empty space that you leave around elements or at the end of rows for your machinery or for people to maneuver around. Regardless of what the context of your project is, if you're applying any kind of patterning, you're always going to have headlands. So they must always be considered and applied before you actually get to the pattern. Now, by saying all of this, the important point I'm trying to make is that before you start applying the pattern, you have to find ways to limit the area of interest or the area where the pattern is going to be applied. The more successful or creative you are at limiting the area that the pattern is applied to, the better your pattern is going to be, and the cheaper and easier it's going to be to draw and to implement. So how you do that will ultimately depend on the context of your particular project. If you don't have many limiting factors, then it's going to probably be more difficult or more time consuming to apply this pattern. But again, this is related to the terrain of your site, for instance. Maybe you don't have any buildings, forestry, fences, or earthworks on your site, but the geography is very limiting. Or maybe you have none of these things and you have a very flat landscape, so the geography is not limiting. But even in those cases, you may have a limiting factor if your site is struggling with drainage, for instance. Now, whatever the case is, the point is that before you get to the pattern, you need to consider all of your limiting factors, whether they are existing ones or proposed ones. We've seen cases where people have unfortunately applied the pattern and planted trees along it, and then they realize that, oh, we need to also put water storages and we need to put access. And this is an unfortunate situation where you would then have to start removing trees and so on. So it gets pretty expensive. It's worth it to take your time to consider the other layers before you actually get to the pattern. Not just because it's going to make it easier to apply it, but it's going to prevent these kinds of costly mistakes. Now, with all of that said, we can take a look at the actual process by which we draw this pattern either by hand or within Google Earth. So here we have this flowchart that looks at the general process. As a first step, again, we're going to spend a lot of time to try and reduce the area of interest as much as possible. And again, regardless of what the context of the project is, one of the ways by which we do that is going to be headlands. And this is such an important element, and it's also one of the most overlooked ones that I felt is important to specifically call it out. But again, there are many ways by which you can reduce the area of interest. So headlands is just one of them, and it's one of the major ones, but there are many others. Now, once we reduce the area of interest as much as possible and as much as is reasonable, we're going to move into trajectories. Now, these are the trajectories of direction of slope of the primary land elements. These are the primary ridge or a main ridge, if that is where the site is located, or the primary valley. This is one of the major issues that people run into when they first try to apply this pattern. They try to be too technically accurate. Every little runnel or wiggle that they have in their contour map, an attempt is made to tackle it by the pattern. And ultimately what this does is creates a very frustrating experience, first of all, and also a dysfunctional pattern that simply doesn't work. If you were to try to apply this pattern on an actual landscape, you're going to struggle a lot. And even if you succeed, it's going to be so unpleasant to work with that people are ultimately going to hate it. And the landscape is in result going to probably degrade. So being too technically accurate defeats the purpose of the pattern. The point of a pattern is to ease management, and if your pattern does not achieve that, then it's not a functional pattern. In many cases, it may not even make sense to apply a keyline pattern if it's going to create a dysfunctional kind of system. Maybe you are going to be better off by applying a simple grid, for example. If that's going to give you the kind of easy management that you need in order to support this landscape and to improve it, then this is probably what makes more sense than applying a keyline pattern. We have heard some people say things like, well, if you don't apply the keyline pattern, then F you, and I think this is such a reckless and dangerous sentiment. Again, a pattern is way down the process of designing landscapes. There are so many considerations that you need to take before you start planning these patterns and applying them. So ultimately, it is the context of your enterprise, the context of you, and all of these other layers that are going to dictate which pattern you should apply and the manner in which you should apply it. Now, we're going to talk about trajectories also in just a moment in order to cover the theory behind how we can use them and the way we can leverage them. Now, once we create our guidelines, then we can start offsetting, but to create our offsets, we are going to use grid overlays. And the idea of using these overlays is something that, to my knowledge, first came through Harry Green from Propagate Ventures. He shared this idea in the Regrarians workplace. When I saw it, I thought that we could also expand on it even further and add additional tools in order to make the creation of these patterns in Google Earth even more accurate. So this is also something that we're going to take a look at in this video. Once we place our grid overlays, we can start creating our offsets. Now, once we create our offsets, we are going to examine our drawing, and if there is a need to make revisions, we're going to do that, and most likely than not, we will have to go back to step 3 and repeat the entire process from there onwards. Now, with the general process covered, we're going to jump into AutoCAD just for a moment to talk about some of the theory behind using trajectories and how offsets work. So here we are inside of AutoCAD, and I have created a very simple line geometry here that we can then begin to offset. So if I select this line and then enable the offset tool, I'm going to set this to through, so that we can have a dynamic kind of offset. Now we can see that when I offset this line up and down from its original location, it is following a certain predictable trajectory. Now the trajectory is dictated by the angle of the geometry. In fact, the trajectory follows exactly the midpoint of the angles of the geometry. So if I were to create a new line by angle and I select this angle here and I'm going to do a counterclockwise, we can see that this angle is 81.27 degrees. So if we were to divide this by 2, it's going to be 40.51. So I'm going to create an angle at 40.51, and this is going to be the midpoint of this angle. So if I create the line here and simply extend it, and now I grab this line and start offsetting it again, we can see that this is going to be the trajectory that it follows. And this applies to this other angle here on the right side. Now we can use this to our advantage inside of Google Earth, or even if we are drawing the keyline pattern using just hand drawing tools. One of the things that the trajectory enables us to do is to predict how our geometry is going to look upslope or downslope from our guideline. For example, if our slope is looking a certain way up here, then we're going to know in advance how our pattern is going to look like relative to that slope. So if it's not going to work, then we don't have to actually spend time to offset the pattern first before we can understand that it's not going to work. We can make changes in advance, and in this way we can save a lot of time. And similarly, if we have a certain slope below our guideline, then we can know in advance how our pattern is going to relate to that slope, so we can make any necessary changes if we have to. The other thing that the trajectory allows us to understand is how many patterns we need to cover a landscape. So for example, if we have a slope that follows only a single general trajectory, then we know in advance that we only need one pattern to tackle that landscape. But if all of a sudden the trajectory of the slope is shifting in direction, then we know that somewhere at this point we're going to need to break our pattern and start a new one. In between our first pattern and our second pattern, we're going to leave empty space. This is going to be the headland space, so that any maneuvers that need to be made in between the patterns can be made there without infringing on any of the patterns. Now, the trajectories, just like we talked about, are actually going to be the trajectory of the direction of slope of our primary land elements. So we are going to draw out those trajectories first, and then we're going to establish the guidelines. This is why the sessions on keyline geography on the Regrarians farm planning program are so important. So understanding what are your primary land elements that you have on your site and where the center points of their slopes are is going to enable you to create these patterns inside of Google Earth, or even if you're drawing them by hand. Another thing to talk about is that we're going to stick to the angular style of patterning. We're not going to be using curves, because this is going to make the creation of the pattern inside of Google Earth or by hand extremely difficult. But to be fair, on most of our projects we are creating angular style patterns, even if we're using sophisticated CAD software. This is because these patterns are much more easy to implement and to work with than curved kind of patterns. If you're creating curved style patterns, you're also going to inevitably need high-end surveying equipment to be able to implement them on the ground accurately. Whereas if you're planning with angular patterns, you can implement them on the ground using very basic equipment, for example, like a map and a compass. Or you can just use your smartphone or some kind of a handheld GPS device. So while curved patterns may, to some people, look more appealing, they are inevitably more difficult to implement and more expensive. Also, if you are applying angular patterns on the land and you're using machinery to implement those patterns and to create management along them, then they are inevitably going to become curved at the angles, because machines simply cannot make these angular turns. They are naturally going to make a curve here at the angle, so you're still going to end up with a more curved looking pattern. So all in all, I think there is a greater argument against creating curved patterns. And besides, in Google Earth, we are already fairly limited with the amount of tools that we have, so we're kind of forced to stick to angular patterns. But ultimately, this is something that will depend on you or the context of your project. But I would say that if you are going to create curved kind of patterns, then you should look into other software, simply because Google Earth is way too limited for creating those kinds of patterns. And finally, with all of this said and done, we can proceed to Google Earth and go through the process of creating these kinds of patterns there. So here we are in Google Earth, and the first thing that I want to do is to change the interface a little bit, just so I can hide certain things that I don't need to see while I'm drawing. So here we are in Google Earth. The very first thing I want to do is to change the interface a little bit. I want to hide certain things like the logo and the navigation widgets that I don't want to see. So I'm going to go under the View menu, And under show navigation, I'm going to set this to never, which is going to hide the widgets. To hide the logo, there is a trick you can do by going under the save image tool. So I'm going to click on that. I'm going to set this to the maximum resolution, and under map options, I'm going to untoggle all of the map elements, and then I'm going to set the scaling to 1%. And with that, I can click somewhere in the viewport to hide that toolbar. And we're going to stay under the save image tool, so it's going to stay open. This is not going to prevent us from using other tools while it is open. It's simply going to force any map elements in the interface to be scaled down to 1%, so they are virtually invisible. And the last thing I want to do is to hide the layers panel. So I'm just going to click on the layers name to toggle it. And I'm also going to do the same thing for the search panel. So now the places panel has been expanded to its maximum. I've already loaded here a folder called the keyline project. If I expand that, we can see that there are 3 other folders within it. The first one is called input. Then we have the folder that will contain our drawing. And then we have a folder for the output, where I'm going to make a copy of the final drawing so that I can export it out from here. Under the input folder, we only have maps that I've already prepared. The first one is a cadastral map, which is just basically an outline of the boundary of the site. Then we have an aerial map, which is just an orthophoto of the site that was captured by a drone. This can give us more clues as to which areas we want to avoid infringing on with our pattern. Then we have a hillshade map, which can give us some indication of the roughness of the terrain. Then we have a flow map. This map could be helpful in creating the outlines of the slope trajectories of the primary land elements, because it highlights where water is draining from and where it is draining to. Then I have a contour map in 2 variants, 1 meter and 0.5 meters. And finally, we have a slope map. So the slope map also comes with a legend. So for instance, if I know that this land is very bumpy, it's very rough, and there are many rock outcrops, then normally anything that goes above 10 to 12 degrees is going to be a potential area to be avoided. So this map could help us to avoid areas that are simply too steep or too dangerous to be creating the pattern into. Under the drawing folder, I have 6 other folders, 1 dedicated to the headlands, 1 dedicated to the slope trajectory outlines, then 1 for the guidelines, 1 for the protractor tool that we're going to be using, 1 for the grid tool that we'll be using, and 1 to create the actual offsets. Now, the first thing that we're going to do is to make sure that the terrain, the 3D terrain under the layers panel has been turned off. This is important because if the 3D terrain is turned on, it's going to inevitably create distortion into your line work. So with that turned off, I'm going to again collapse the layer panel. Then as per our actual process, the first step is to begin reducing the area of interest. And for this particular site, this is going to most of all come down to establishing where our headlands are and what the headland width is. Now again, the headland width is simply the empty space that we're going to leave around elements that we want to avoid infringing on with our pattern. And what the headland width is going to depend on your particular context or the context of the project. Normally, this is going to factor in the width of the largest equipment that is going to be navigating this site. So if this is a tractor, then that is the largest equipment. Just make sure to also factor in any implements that are being dragged by the tractor. This could also be a wheelbarrow, or it could also be just a person. In our case, we're going to assume that a tractor is going to be used on this site. So how you determine the headlands is a matter of debate, but normally you're going to take the width of the equipment and multiply that 2 to 4 times. Normally we are going to multiply it twice. So if our tractor is, let's say, a 5 meter wide, then we're going to say that the headlands are 10 meters. Now we have a section on headlands under the access chapter of the Regrarians handbook. So if you're interested to know more about them, you can read through that. For now, for our example project, we're going to assume that the headland width is going to be 10 meters and it's going to be a fixed width. That is, we're going to apply the same headland width all throughout the site. But headland width can vary, and this is again something that depends on the context of your project. For example, headlands that run parallel to a fence are not necessarily as wide as headlands that run perpendicular to a fence, simply because in the latter scenario you need more space to turn machinery. But just for the simplicity of this example, we're going to apply headlands that are of a fixed width of 10 meters. So to begin applying the headlands, I'm going to open up the aerial map just so I can inspect which areas we may want to avoid applying the pattern to. Now, obviously, this area here in the middle, where the dam is and where we have these riparian buffers, is going to be one of those that qualify. I'm also going to turn the contour map. Now, this is going to allow us to take a look at where we have large valleys where a lot of flow may be draining through. Now, in many cases, when we see secondary valleys like these, we may want to fence them out or dedicate them to riparian buffers or to wildlife corridors. And in this case, this is what I'm going to do with this secondary valley. We're going to isolate all of it and leave it to revegetation. So we're going to establish headlands around it. So I'm going to head over to the headland folder and I'm going to bring up the polygon tool. This window is going to appear under name. I'm going to call this headland 1, and we're going to take a look at applying style and color later on. For now, I just want to start tracing out this valley here. So I'm going to follow the edge of the valley somewhat. One thing to bear in mind is to try and keep everything simple. Again, we don't have access to sophisticated tools, so when we start creating offsets from these headlands and from other geometry that we create, it's going to become more complicated to do that if we have many turns or many breaks in the lines. So once I have created an outline for the headlands, for instance, I'm going to come back now and look at it and see where I can simplify it. You can just left click, hold and drag on any of these points on this geometry in order to move them around. If you want to delete a certain point, you can again just left click on it to highlight it, and you can press the right mouse button or just press the delete button on your keyboard. So for instance, I'm going to think, well, do I really need this point here? Because later I'll have to struggle to create an offset that takes into account that there is a break in the line here. So in this case, I'm going to left click on it to highlight it, and I'm just going to right click with my mouse to remove it. I'm going to do the same thing for this point here and for this point as well, and for any other point that I can find that I can optimize. So I went through the entire headland and I removed as many points as I could. So now the line is much more simplified. From here, I'm just going to click on OK to accept this headland. And now we have to think, well, are there more headlands that we want to establish? Obviously, we're going to avoid this entire forestry section here, so maybe we can establish a headland around that. Now, in this case, we don't necessarily need to use a polygon tool, so I can click on the Add Path tool, and I can use that. I'm going to call this Headland 2, and I'm going to create an outline around this forest. Again, trying to keep the geometry to an absolute minimum. I'm going to go under the Style and Color tab, and I'm going to set this to a width of 2, and I'm going to select a magenta color, just so I can have some consistency. And once I'm done with that, I'm going to press OK. Now this gives us somewhat of an idea of the areas that we want to establish the pattern to. We have this massive ridge here, and then we have this entire section here that looks like it has a primary valley and a couple of ridges on the side. So again, we are only considering the primary land elements. I'm going to completely ignore small valleys like these ones or like this one. What we're looking for is the primary valleys, primary ridge on this side, and another primary primary ridge on the other side. And on the southern side of the site, we have just a massive primary ridge. So I'm going to try to keep that into perspective and not get bogged down into trying to tackle every little change that we have in the contour map. So I'm going to select the trajectories folder and I'm going to open up the path tool. For style and color, I'm going to set this to something like yellow, and I want to make this a little bit wider. I'll keep the opacity to 50%. I don't want it to be fully opaque so it doesn't dominate the drawing. This will become important later on, I think. And I'm going to call this trajectory 1. So I'm going to set a guideline here and I'm trying to follow just the general direction of slope. If you can avoid creating breaks in the trajectory line, then this would be ideal. So for instance, I could have just done this and this in order to stay perfectly technically accurate in relation to this slope. But if I could get away with having just a simple line like this, then I'm always going to do that, unless the objectives of the project dictate otherwise. So I'm going to leave this line here as it is, and I'll press OK. Now I'm going to create another trajectory just by opening up the path tool again. I'm going to call this T2, and then I'm going to create a trajectory for this primary valley here. And I'll press OK on that. And then we're going to have the third trajectory, which is going to be this ridge here. I'm just going to pick up the mid slope. And I'll press OK on that. Now we may also want to have a pattern in this small patch of land here. So I'm going to create another trajectory for this primary valley here. I'll call this T4, and another trajectory for the primary ridge here. So I'm going to call this T5. And now finally we come onto the big ridge. Now, to tackle this ridge, we may have to have more than one trajectory. So for instance, we may have to have one here. I'm going to call this T6. And just adjust it slightly. I'm just thinking about how is the guideline going to look here and where are there going to be breakpoints into the angular geometry. So we may want to have a guideline that breaks here, then proceeds this way, and then breaks here at the center point of this slope, and then continues on towards the south, or it just continues on towards the southeast. So I'm going to press OK on this one, T6, and I'm going to create another one that is right here at the middle of this slope. So this is going to be T7. Now, none of these are set into stone. If we have to make changes, then this is going to become obvious when we start creating our offsets. For now, they are a good starting point, and this is all that matters at this point. Now, before we proceed onto the guidelines, we can first of all create the offsets for the headlands. Now, this is a step that I could have completed right when I was creating the headlands. It doesn't really matter as long as you do it before you start creating your offsets. So normally when I'm doing the headlands, I'm also going to do the offsets for them right there and then when I first outline them. But because we're using Google Earth, I kind of tend to leave the offsetting of everything right to the very end because it is one of the most time-consuming steps in this process. I'm going to do it right now, and then we're going to proceed to creating our guidelines and then our offsets. So the process of offsetting the headlands is going to be different than the one we use to offset the actual keyline pattern guidelines. To create the headland offsets, I'm going to start from one end of the headlands and zoom close into them. And then what we're going to establish is a guideline that extends out from the headland to the extent of the headland width that we determined, which is 10 meters. So now I'm under the headlands folder. I'm going to open up the path tool, and I'm not going to give these any names. They're going to be deleted soon after we create it. I'm just going to set a color for them just so that they stand out a bit. I'm going to set them to something like bright green. And I'm going to set the opacity to 100. And now I'm going to go under the first point of this headland and zoom in using my mouse cursor. And I'm going to extend out the line. Now to see the actual measurement of this line, I can go under the measurements tab and I set this to meters, but you can use any of the units that we have listed here. And I'm going to grab the endpoint and just extend it out until we reach the width that we determined for our headlands. So we have 10 meters for this one. I'm going to press OK. Now we can move on to the other point of our headland. If I ever need to see where those points are, I can just select the headland under the headlands folder and right click on it, and it's going to highlight the points. So we have another point here and another one here, and then a few more down the line. So I'm going to zoom into this point and create another path here. I'll extend this one out again 10 meters. And then I'm going to zoom into this other point. And then we had a few points here. So we have 3 more points down the line. Now, by the way, you can use shortcuts to reach most of the tools inside of Google Earth. So for instance, if I want to bring up the path tool, I can press Ctrl Shift and T, and this is going to bring up the tool. So I don't have to actually click on it every single time. And finally, we have this last point here that I'm going to extend out 10 meters. Now all that we need to do is to connect the endpoints of all of these extensions. I'm going to go under the headland folder and create a new path. Again, I'm going to make this magenta color, reduce its opacity to 50. And now I'm going to zoom in and start connecting these points. Now you can move the screen using just the arrow keys on the keyboard. When you're in this mode where you have a tool enabled, then you're not going to be able to use the middle mouse button to pan the screen, so you have to use the arrow keys on the keyboard. And finally, we have this point here, which I'm just going to end at the boundary. Now I'm going to call this headland 1.A. The original one will stay as headland 1, and then we're going to have headland B, headland C, and so on, extending again from the original headland 1. Now these extensions, I can Shift select all of them by first of all selecting the first one and then holding the Shift button on the keyboard and clicking on the last one, and then I can right click on them and just delete them. So here I have the first side of this headland offsetted from. Now I have to do this on all other sides of this headland as well as on the other headland that I established. Also, the boundary of the side itself can be a headland that we can extend from. So I'm going to also do that after I complete the extensions of all of these headlands. Now, something that I completely forgot when I was creating the extensions is that you should never make the extensions out from the angle where the line is breaking. The extensions should always be made from the segments in between the points. This is because if you make an extension from an angle, then the extension is not going to give you the 10-meter width in between the segments, because an extension made from an angle is either going to be shorter or longer than the one that you actually need. So when you're creating these extensions as guidelines, always make them out from in between the straight segments. So if I make an extension here that is 10 meters, and yet I make another one that is from the angle, and it's supposed to be 10 meters, we can see how it's going to be a little bit shorter or longer. And this is going to vary depending on how steep the angle is. So if I were to, let's say, make an extension from the segment that we have here and measure 10 meters from that, and then I make another extension from the angle that we have here and measure 10 meters from that, we can see that 10 meters is all the way back here. So if I try to then connect these angles, I'm inevitably going to get a smaller width than the one that I actually determined. So never make the extensions from the angles, always from the straight segments in between the points where the line breaks. And this is going to be more pronounced on angles that are more acute, whereas on angles that are not so acute, then this is not going to be so visible. But in the end, you're still going to get offset that is not the width that you actually wanted. So now that I created and corrected the offset from all the headlands, I'm also going to create an offset from the boundaries, because the boundary is also in a way a headland, and it is going to be at the end of our rows anyway, so any machinery will ultimately have to make a turn there unless it starts hitting into the fence or any of the vegetation here or the road. So this is the next step that I'm going to take. Again, I'm going to create a time lapse from this, because it's basically the exact same process as offsetting from any of these headlands. One thing that I would say though is that when you're creating these extensions to use as guides, always try to create a 90-degree extension to the boundary or the line from which you're extending. Now, obviously in Google Earth, you're going to have to eyeball this, but try to make it more or less 90-degree angle. If you try to make a diagonal extension, then obviously you're not going to get the width that you actually wanted. Now, all you really need is to have two extensions for every segment, because a line is always going to be straight between 2 points. So once I've made two extensions, I can just connect these 2 points and just align the line with the ends of the extensions. Now, once I have created all of these headlands offset, I can just connect all of them together so that they don't intersect each other. This is just going to make up for a cleaner drawing. So everywhere where we have some kind of an intersection between them, I'm just going to bring them all together. Now all of the headlands and their offsets have been complete, so we can move on to the next step, which is creating the guidelines. I'm going to bring back the trajectories, and now I'm going to select the guidelines folder, and I'm just going to delete this other folder that I created earlier. And then I'm going to open up the path tool. I'm going to give this a cyan color like before, and I'm going to zoom into the eastern corner, and I'll start drawing out the guideline from here. Now the very first pass of the guideline is going to be eyeballed. That's okay. The point is just to have a starting point. What I'm trying to do is to split the angle of the guideline by half from the trajectory line that I have. So this angle right here, I'm trying to make it so that this yellow trajectory line is splitting it more or less in half. The first time I do this is going to be eyeballed, but then I'm going to go back and use a tool to make an accurate measurement, and I'm going to make an adjustment to the guideline. So all I'm trying to do now is to just create the guideline, and then I'm going to use that as a starting point to adjust it. Now I'm going to position the guideline here in the middle of the slope, more or less, just so I have more room to work with. I'm going to proceed to this other trajectory line, and we're going to finish off at the boundary. Now, of course, I'm trying to keep also to the traditional keyline geometry where we have the line sloping towards the center point of the ridge lines. I'm not going to become overly obsessed about that, however, because again, the point is to create a functional pattern most of all. If you have to make compromises at some places for the overall good of the pattern design, then this is a good judgment call. For example, like if I put the guideline right here, it's not necessarily going to be perfect when I start offsetting it up and down the slope. There may be some areas where the geometry is not flowing from valley to ridge, and that's okay if it occurs just occasionally. What you're looking for generally is to have a pattern that is, let's say, 70 to 80% technically accurate, and then for the remainder you can make compromises if that means that you can keep the pattern simple. So again, we are not necessarily aiming to create a pattern that is perfectly technically accurate. If that's possible without it being at the expense of the ease of use and application of this pattern, then that's great. In most cases, however, it is going to come at the expense of that, so we should avoid falling into that trap. Now, I'm not entirely happy with the way the angle here is being split. If I want to adjust the angle, I'll have to move the guideline on this side, because this wing controls how the angle is looking on the right side of the trajectory line, and this wing will control the angle on the left side. So it's kind of a balancing act to get all of these angles right. So you just have to go back and forth and keep adjusting them. We're going to bring in our protractor tool in just a moment in order to get these angles as close as possible to being perfectly split by these trajectory lines. And now this is it for the first guideline. So I'm going to establish all of the other guidelines as well. I'm going to call this guideline 1 and press OK. Now we can move on to this area here. This is going to be our guideline 2. I'm going to make this one somewhat steeper than the others. So something like this, more or less. Obviously, we have trees and everything here. Just for the purposes of this example, I'm ignoring that. And this is it for this guideline. Now I can move on to this one. This will be our guideline 3. Now I can already see how the trajectory line that I established is not accurate, because it is just impossible to split the angle here in half with this trajectory line if we were to follow it. So I can either ignore the trajectory line or simply change it now. Otherwise, if I try to follow it, then my guideline is going to have this kind of angle, which is not going to work because we still have all of this landscape here that we want to cover. So what I'm aiming for is a guideline like this instead. Something like this, or it could also go this way. So we can also see how the second trajectory line here is also not accurate. So we will have to change it or simply ignore it. Now, of course, these are just guideline trajectories, so you don't necessarily have to follow them. I'm just going to redraw them. So I'm going to press OK on this guideline 3, and I'm going to right click directly in the viewport on the yellow line and go under properties. And now I'm just going to adjust the angle. So we will have something like this. This already makes it obvious how if I start offsetting this line now, it's not going to necessarily do a perfect coverage of this slope. If we wanted perfect coverage, maybe we could still keep it here and we can simply adjust the angle like this. This may necessitate having a second pattern, but just from experience, I know that these kinds of guidelines on these kinds of slopes are still going to work. So in this case, I'm going to disregard the trajectory line, or maybe I'm going to just leave it like that. it can still sit there. I don't have to necessarily follow it. And I'm going to try to adjust the other trajectory line as well to see if we can get an even split here on the angle. So we're going to need to have something like this. I'm going to make a new folder under the drawing folder, and I'm going to call this forestry. And I just want to make an outline that this entire area within our headland is a riparian buffer. So I will select the forestry folder, and I'm going to open up the polygon tool. I'm going to go under style and color, and for lines I'm going to set this to green, and for area also to green. I'll set the opacity of area to something like 50, and to line also to 50. And now I'm just going to trace the insides of this headland that we use to outline this area with. I'm going to call this riparian buffer zone. Now that we have our guidelines and our trajectory lines and our headlands established, we can proceed to bring in a protractor tool that is going to allow us to accurately split the angles of our guidelines so that later on we can create equidistant offsets from them. Now, there are a couple of ways of doing this. We can either adjust our guideline in relation to the trajectory line, which is what I would normally do, or alternatively, we can adjust our trajectory line according to our guideline. This will become clear in just a moment. I'm going to click on the protractor folder, and I'm going to head over to the Add Image Overlay button, and I'll click on that. I'm going to call this protractor, and I'll click under the Browse button. And under the project files for this video, you're going to find a collection of overlays that I've created. Most of them are different variants of a grid, which we're going to use later on to create our offset. But you're also going to find a couple of variants of a protractor tool. One has a opaque background and the other one has a transparent background. I want to load the one with the transparent background, so I'm going to select it. This is variant 2, and I'll click on open. This is going to bring in the overlay. Now I want to scale it down a bit, so while the overlay is still active, I'm going to hold the shift button on the keyboard and then left click, hold and drag on one of the widgets of this overlay. So this is going to scale it uniformly. Now I'm going to put it to the side for just a moment, just by left clicking, holding and dragging on the crosshair in the middle. I'll press OK on it for now. And I want to turn off the aerial map and the contour map because we don't need them at the moment. So I'm going to go back to the protractor now, and I'm going to right click on it and choose properties. And I'm going to left click, hold and drag on the center to move it into place. I want to also rotate it around. So I'm going to left click, hold and drag on this widget on the left hand side. Now what I'm looking to do is to measure the angle of our blue guideline. And to do that, I just have to orient one of the sides of the protractor with one of the segments of the guideline and make sure that the angle is at the 0 of the protractor. And with that done, I can press OK. And now we can see that we have roughly an angle of 120 degrees, or 122 to be precise. So the middle of our angle is going to be exactly at 61 degrees, which is at 61 right now, I think, or it's going to be somewhere around here. So I could just press the right mouse button directly on top of the yellow guideline to access its editing, and then I'm just going to left click, hold and drag on the endpoint to position it into place. And now we have to repeat this process for every angle that we have on our guideline. In this case, we have just another one. So I'm going to right click on the protractor and go under properties so I can move it around to position it into place. Again, I'm going to do the exact same thing, just align the one side of the protractor with the guideline and make sure that the 0 is right at the angle, and I'll press OK on that. And we can see that we have an angle of just about 170 degrees. So the middle point is going to be at 85 degrees. So I can grab the guideline and just move it to 85, and I'll press OK on that. And this is it for the protractor for now. I'm going to hide it. And now we can move on to creating the offsets using the grids. So I'm going to select the grids folder. And again, I'm going to go under the Add Image Overlay button and click on that. I'm going to call this grid 1 because we're going to bring in more than one grid into this, and you will see why in just a moment. And I'm going to click on the Browse button. And there are quite a few grids in here, and you can see that the color is between green and red. This is because we're going to have to bring in more than one grid, and we're going to alternate the grids so that every time that we copy and paste a grid, it's going to be a different color so that we don't get confused about which grid we have to follow. Now just stick with me, this is going to become clear in just a moment. I'm going to bring in grid 02, the red version of it. So I'm going to double click on that and it's going to load it. I'm going to press OK on that. Now we have to choose the offset distance that we want to have before we start utilizing the grid. Let's say that we want to have an offset distance of say 15 meters. So what I'm going to do is create a new path, and I'm going to create an extension from the guideline that I have. I'm going to open the measurements tab and create an extension that is 15 meters, and I'll press OK on that. And now we can grab our grid and right click on it and choose properties. And I'm going to rotate it here into place until one of the lines of the grid is aligned to our guideline. So I'm going to position it into place and rotate it so it is aligned as closely as possible. And now I'm going to grab the widget here on the grid and I'm going to scale it to until we have a 15-meter offset between the major lines of our grid. I'm just going to make a change to the extension that I just created. I'm going to press OK on the grid for now, and I'm going to right click on the extension, and I just want to make sure that it's at 90-degree angle. So I'm going to make sure it is also at 15 meters, and I'll press OK. Then right click on the grid again and go under properties, and now we can scale the grid down. So I'm trying to make sure that the distance between the major grids is matching our extension line. We will only have to do this once because we will simply create a copy of this grid and replace it with the green one without having to reload the entire grid. So this is just about 15 meters. So I'm going to press OK on that. And our grid is already aligned to our guideline on this segment. I'm just going to position it like this because I want to have more of the grid extending further into the landscape so I can follow these guides. And I'll press OK. Now we have to create another grid that covers this part of the landscape so that we can offset from this guideline for 15 meters. And then yet another grid that is going to cover this area here. So I'm going to just select the grid overlay under the grid folder, and I'm going to press Ctrl C and then press Ctrl V on the keyboard to make a copy. And I'm going to rename this to grid 2. I'm going to right click on it and go under properties, and I'll go under browse and I'll select the green variant of this grid. So this is grid 02 green variant. I'll press OK, and I'm not going to close the window just yet. I want to reposition this grid. So I'm going to grab the center and move it into place. Make sure not to scale the grid because at the moment it's scaled accurately to give us 15-meter intervals. So make sure not to scale it. You can rotate it and move it around, but don't scale it. So I'm going to position the grid here. You can scale it in the other direction if you want. Just don't scale it on this axis or on whichever axis you use to determine the offset spacing. So I'm going to scale it down a little bit so it doesn't intersect so much with our other grid. And I'm going to do the same for the red one. And now we have to do this one more time, bring in the grid again, and we're going to have the red variant on this side. So we're just alternating the colors so we kind of have a clearer picture of how we should follow these grids. So I'm going to create a copy of grid 2 by pressing Ctrl C and Ctrl V again. I'm going to go to properties, call this grid 3 and click under browse, and then select the red variant of the grid again and click on open. And I'm going to position this on this segment. And now with all of this done, I can press OK on this, and we are finally ready to start tracing these grids so we get our 15-meter offset. I'm going to delete this extension line that I created, and I'm going to select the offset folder, and I'm going to go under the path tool. And this is where it matters how you start tracing these lines. You have to choose a direction, because otherwise, if you just trace one segment and then another segment, you're going to struggle to connect the lines together later in a cohesive whole. So it's better to just make one path for every line that you make. So I'm going to start from the southeastern corner and trace all the way to the western corner. So I'm going to start from here, and I'm going to start the line from the edge of the headland. I'll just set a color for this, and I'm going to make it something like cyan and make it a little bit wider, and I'm going to set 100% opacity. So I just have to trace these lines now. And I'm going to, again, end them at where the grid intersects with the headland. And I'll press OK. Then I'm going to press Ctrl, Shift, and T on my keyboard to start another path. And I'm going to go back here to beginning and start tracing from the headland again. So we can see how the red grid is intersecting in the green one right here at the angle. This is why it was so important to have the angle of the guideline evenly split. If the angle was not evenly split and we just aligned the green grid to this segment and the red one to this one, then our rows were not going to be intersecting in such a clean way. The green grid may be somewhere else or right here, and then we will start having to adjust the line, and it would not give us equidistant spacing. So it is crucial to make sure that the lines of your guideline are evenly split by the trajectory line before you start overlaying these grids. Now I'm going to press Ctrl T again and just continue with the tracing. I can even also start from this end. It doesn't really matter as long as it's one continuous line and it's not broken down into individual segments. So now that we ran out of grid to trace, all we have to do is to simply reposition these grids. So I'm going to right click on the red one first and position that, and then reposition all of the others too. I'm just going to place all of these lines that I just created under the offset folder, and then I'll right click on the first grid, move that into place, then the red one, the green one, and finally the other red one. Now this should be enough for us to be able to finish this landscape. I'm just going to turn on the contour map for a moment to make sure that we are moving in the right direction. And this looks more or less good to me. So I'm just going to start tracing again, selecting the offset folder and going back to the path tool. And again, starting from the headland here. Now you can see how our guideline here, or the trajectory line rather, changes direction. And again, we don't need to follow it necessarily in this case. If we need to follow this trajectory line as it is right now, we will have to create a different pattern that starts from this point. So our pattern that we currently have is going to break and a new pattern is going to start. And this may be something that we want to do, and maybe it's a good idea to demonstrate how to do it now. So I'm going to turn off the grids and turn off the contour map for a moment. And all we really have to do is to establish a new guideline here. So I'm going to turn on the protractor and I'm going to right click on it and choose properties. And I'll bring it here. Now I want to keep the existing segment that we have of our guideline. All I want to do is to adjust the segment that is going to come to the right. So this is the only one that is going to change, because the one on the left hand side is already pretty good in terms of the topography that we have. So I'm going to bring the protractor here and I'll press OK on that. And now we have to determine what kind of an angle we want to have. Now I'll turn the contour map again. Let's say that the pattern that we want to have here, again, follows this direction on this side, but then it shifts like that. So if we want to have an angle for this new guideline that is evenly split by the trajectory line, we know that we're going to need to have an angle that is in total around 58 degrees or so, because the angle on just this side is around 28.5 degrees or so. So we're going to have an angle that is around 57 degrees, something like that. So I'm going to leave the guideline as it is for now, and I'll press OK. I can turn off the protractor and I'll move this under guidelines, and I'm going to call this guideline 4. And I need to just reposition it now so that it is at 15-meter offset from the previous guideline that we have here. So I'm going to turn on the grid and right click on it and just reposition it so that it's on a major line. And now I just have to move this guideline. So I'm going to right click on it, choose properties and move it here. Now just to verify with the protractor that we still get the even angle split. This more or less looks correct to me, so I'm going to turn off the protractor. The other thing we have to do is to create a 10-meter offset from this other guideline, because we want to establish a headland from here, because this is where we need to have an empty space so that we're going to have a distance between these two patterns in case any maneuvering needs to be done here. So to do that, I'm just going to create an extension from this guideline here. I'm going to set a different color for this, turn on the measurements tab and create a couple of lines here that extend 10 meters and another one here. And I'm going to go under the headland folder and just extend a headland that connects with the endpoints of these two lines. This one is going to come somewhere like this to connect with the existing headland. And I'm going to leave this like this for now. I'm just going to set a different color for it, like the other headlands have. And I'll press OK. Now we know that if we start offsetting this new break in the pattern that we created and we offset it downslope, this is the maximum extent that it should have. It should not cross this headland. So now we can bring back the grids and continue our offsets. So we have the red grid first. Now I don't want to offset any more on this area here from the original guideline that we have. So I'm going to position this grid this way and rotate it like that. And I'll press OK on that. And I'll go under the offset folder and turn on the path 2 again. Set this to cyan, 5 at width and 100% opacity. And now I can finally start offsetting again. I'm going to move these lines to the offset folder. And now I can turn off this grid just to inspect what I've done. And I can delete the 2 extension lines I created, and I can even turn off this headland. So now we have 15-meter offsets just like before from this guideline going downslope, but we have a 10-meter offset between this pattern and this pattern, which is going to serve as turning space at the end of these rows if it's necessary. Now all we have to do is to complete the pattern on this area here. So we have to offset from this side, offset from this side, and then also offset from this side. So I'm going to just do this by first of all repositioning the red grid on this side so I can complete this area. I'll press OK on that and then enable the green grid, and this is also already positioned into place. And finally we have the other red grid. So I'll go under the offset folder, toggle on the path 2, and I can actually complete this guideline that I have here just by selecting it, and I'm going to position it here and make a new point. And now this one is complete. So I can go back to the offset folder and start tracing these other lines. Now in these kind of tight corners, it may get a little bit confusing when you're doing these offsets because the grids start overlapping, but you kind of get used to it at some point. And I think this is the last one. So I'm going to press OK on this and turn off the grids to see if I made a mistake anywhere. And this looks more or less correct, I think. I just have to reposition this line so it ends at the headland here. I'm just going to turn on the grid to make sure I'm following the lines. And with that done, I'm going to press OK. So I think this pretty much completes it for this area. If I want to change the style of all of these offsets all at the same time, I can just apply a style to the entire folder. So if I'm going to just right click on the offset folder and go under properties, and under style and color, I'm going to click on the button where it says share style. And now I'm going to adjust the width of all of these lines to maybe 2, and then change the color to something like, let's see if orange looks good. The guidelines, I want to keep those looking differently, because if we have to apply this pattern on the ground, then we can just mark these guidelines on the ground and then start offsetting from them. So I just want those to be in a different folder and for them to stand out from the offsets. So I'm going to right click on the guideline folder and apply the same style to them. They're going to be kept like this, cyan and slightly transparent and wider than the others. So press OK on that. Now all we have to do is to create the offsets for the remaining 2 areas following the exact same process. I'm not sure that it's necessary to do all of this in real time, so just to save some time on this video, I'm going to create a time lapse for creating the offsets for these remaining 2 areas. So I established the angle split for all of the angle segments of this guideline, so I can just proceed now to overlay the grids and to create the offsets. So I'm going to enable the first grid again. It already keeps to the 15-meter interval that we created for it, so I don't have to change anything. I just have to rotate it into place here. Now we're going to have 4 grids in this case. And with that done, we are ready to trace. So I'm going to head over to the offsets folder and start a new path. And I'm going to trace from the right-hand side towards the left. Now we have the offsets created for this field, so the only field left is this one to the left. So I'm first of all going to again adjust the style for all the offsets by going under the properties of the offset folder and setting the orange style and reducing the width and increasing the opacity to 100, and I'll press OK. I'm also going to trim the corner here of the guideline to the edge of the headland. Now you can see I didn't do a really good job at overlaying the grids properly or tracing them very closely, but this is because I'm just hurrying up now to save some time on this video. But if you zoom in close and you're careful with your overlays and your tracing, then you can be pretty accurate, I would say. So I'm going to head over now to a small area of land here, and I'm going to create the offsets for this. And again, I'm going to adjust the style of all of the offsets by going under the properties of the folder and setting this to orange and reducing the width. So now with all of this done, I can disable the trajectories altogether and collapse all of the folders, so we don't need to see everything. And this is all of our patterns complete. Normally, you would go and examine to see if everything looks good and if you can optimize it somewhere or make corrections. In this case, I'm not going to do that just to save time on the video, but this is what you would normally do when you're creating these patterns. Now, if this is just for a basic concept and this is what this is really, then you don't really need to do that. But if you're using CAD applications, then this is a normal part of the process, just making revisions and optimizing as much as possible, making sure that these sharp corners are not too sharp for the kind of machinery that you're going to be using, and in general making corrections anywhere where you can see errors or areas that can be optimized. So now that I've completed the drawing, I'm going to just grab everything that I want to put under the output folder. So this is going to be the cadastral map, the offset map, the guidelines, and the headlands and the forestry folder in this case. I'm going to move all of them under the output folder. Alternatively, I can just grab each one of them and make a copy of them under the output folder. And this is what I'm going to do in this case so that I can keep my drawing as a working file and the output I can send to other people. So I'm going to grab the guidelines, the forestry, the headlands, and the cadastral map and put all of them under the output folder. And I'm going to disable the visibility for the drawing and just enable the output visibility. Now there is one headland line that I don't need to have here, and this is this one. So I'm going to untoggle its visibility. Another one that I may want to put under the output folder is the contour map. So I'm going to make a copy of that and place it there. So just to recap, I'm going to open the flowchart again so we can talk about the process that we used. First of all, we reduced the area of interest. In this case, we used headlands most of all, but you can of course use other things to reduce this area of interest. For example, if we had very steep slopes indicated by our slope map, we would isolate those and we would not create any patterning there. And after we reduced the area as much as possible, we created the trajectories, and these were only factoring the primary land elements. We did not pay any attention to anything other than the primary land elements when we were creating these trajectories and consequently creating our guidelines according to them. So once we created our trajectories, we started focusing on the guidelines, and we used the protractor tool to make sure that the angle of the guideline is evenly split by the trajectory. Alternatively, we adjusted also the trajectory to make sure that it evenly splits the angle of the guidelines. So you could go either way about it, depending on the context of the situation. Once we created the guidelines, we imported the grid overlays and then positioned those correctly and established a scale just by using a simple line inside of Google Earth to determine a spacing, and then we scaled the grid according to that extension line. Once we determined the scale for the grid, we positioned them in relation to our guidelines, and we also used alternating color for grids. So if we had to tackle different sections of the landscape, each section was tackled by a grid that was using a different color so we don't get confused. Now with the grids overlaid, all we had to do then is to create our offsets. Now normally I would create the offset for the headlands at the time that I'm creating the headlands, and this is what I did also in this case, and this is what I always do if I use CAD software, but you could also leave the headlands offset for the end just before you start offsetting your guidelines. Now before we wrap this up, there is one last thing that you could do if you want to take this drawing a little bit further, and that is to add annotations. Now you can add those in different ways. One way would be to, for example, add descriptions under some of the elements here. For instance, we may take, let's say, this guideline and go under its properties and then add descriptions here to state how you are envisioning that this area is going to be implemented using this guideline to offset from. Another way to add descriptions is to add overlays of text. So if you have some graphic application like Photoshop or even the free GIMP or anything really that can add text and export the text with a transparent background, then you can bring annotations inside of Google Earth using the same overlay functionality that we've been using to bring in the protractor or the grids. So for instance, here I have a text inside of Photoshop, and I've simply written down the word headland. So in this case, it is in white, but if I turn it into black, you can see that it just says headland and we have no background. So I'm going to make this white, and then I'll go under the file menu and choose to save as, and then I'll navigate to a location where I want to save it to, and I'm going to choose to save it as a PNG. This is going to ensure that the transparent background is retained. Once I do that, I can go into Google Earth, and then through the Add Image Overlay button, I can browse to the location where I exported that text, and we can see it here together with a lot of other icons that I've prepared for you under the project files. And then I'm going to double click on that and bring it inside of Google Earth like that. I can hold the shift button down and then left click, hold and drag one of the widgets at the corners to scale the text down. And I can place this annotation somewhere here to denote that the empty space here is taken up by headlands. And I can press OK on that. And now this text is going to stay there, so whoever inspects the drawing can view it. Now you can add as many annotations like this as you want. One thing that I will say is that if you're preparing these kinds of overlays for annotations, just make sure that the image does not exceed more than 512 pixels wide, because if you have many annotations, then they may slow Google Earth down, because these are, after all, images that Google Earth has to load to display them. Another thing is that it is a good idea to make the image a perfect square. So in this case, it is 256 pixels wide and 256 pixels high. This is going to give us a perfect square, and this is going to ensure that the text or whatever overlay it is does not get skewed inside of Google Earth. I've already prepared an entire folder of annotations here. So I'm going to put this under the output. And so if I load this up, you can see that I just added text all throughout the drawing to explain what the different elements are, but the text can be anything. This is one way to annotate. Another way would be to use place marks. So if I add a place mark here, it's going to place it in the center. And you can see that instead of the default place mark style, which is just a pin, I have placed a text. So if I delete the title of the place mark, this is going to reveal just the style that has been applied. And it's just the exact same text that I have here for the guideline, except that the guideline text here is an overlay and this one here is a place mark. And there is a little bit of a difference with how they behave. So if you want to add such a custom place mark style, you can just click on the button to the right side of the name field. And then this is going to open the library of place mark styles that you can use. These come by default with Google Earth, but you can add your custom ones. There is this add custom icon button in the bottom left corner. If I click on that, I can browse to a location for the icon, or I can load one from the internet. So under icon location, you can just copy and paste a link that goes directly to a certain image that you want to use. But if I click on browse, I can navigate back to the same folder that contains all of these icons, and I can choose, let's say, riparian buffers as a text. Then I'm going to click OK, and it's going to come up under the list of custom icons here. Now for some reason it doesn't appear now because the menu got bugged, but just press OK and this is going to load the place mark so you can move it around. Now, one of the downsides of applying place marks in this way is that you cannot rotate them. Instead, if you rotate your screen, the place mark is going to rotate with it. Also, if you zoom out, you can see that the place mark is going to scale up in relation to how far zoomed out you are. And if you zoom in, it's going to scale down. Now, you can adjust the scale of the place mark, but again, it's still going to scale up or down depending on your level of zoom. So if you go under the style and color tab, we can see that under the icon section, we can apply a certain scale. Let's say that I want to make this a scale of 1. I can type 1, and now again, if I zoom in and out, it's still going to scale up, but just not as much as before. I see this as a downside because if you have many place marks throughout your drawing and then all of a sudden you load the drawing or one of your clients loads the drawing, then it can become very visually cluttering. So for this reason, I don't usually use place marks for text annotations. Instead, I use the image overlays. And so with this said, I think this wraps it up for this video. I hope that this session hasn't been too long or overwhelming, and that it has given you ideas on the different ways by which you can use Google Earth to create basic concepts like these. Thank you for watching, and see you in the next session.